Hello everyone, welcome to Math with Allison. Today we're continuing our series on derivatives. If you haven't already, make sure to check out some of my previous videos. They're linked in that little eye in the corner. I'll get you there. Otherwise, today we're specifically talking about the product rule and how we can apply it. So let's go ahead and dive into it. Before getting specifically into the product rule, I want us to use the limit definition of a derivative. So this is going to get us the first derivative without using the product rule. So we're going to go through torture in order to learn how we can use this shortcut. So let me go ahead and fill some of this in. We have the limit as h approaches 0, and now I'm going to plug in x plus h as my input. So here I have x plus h squared times e to the x plus h. And now I'm going to subtract my original function, x squared times e to the power of x, and all of this is being divided by h. I'm going to go ahead and FOIL this out a little bit. Alrighty, so notice right here, I've changed the e to the x plus h into e to the x times e to the h. And then I also FOILed out this guy right here. So I'm going to go ahead and distribute that out now. Alrighty, so let's notice that each of these terms actually have an e to the x in common. We have e to the x, e to the x, e to the x, and e to the x. Since that e to the x has nothing to do with h, and we're taking the limit as h approaches 0, we can actually take out the e to the x. It has no h, so it doesn't make a difference. So what I'm going to do next is I'm going to regroup some of these terms. I'm going to regroup the x squared e to the h with the x squared since they both have an x squared in common, leaving these guys to be together. So I'm going to split these up into two separate limits actually. Okay, so like I said earlier, these both have an x squared in common. And so just like we did with the e to the x, since that x squared doesn't have an h, we can actually bring it outside the limit. So I have e to the x on the outside, and then with this individual limit, I have an x squared on the outside times the limit as h approaches 0. Now with this other limit, they all have an h in common as well. So I can go ahead and pull that out. I pull out an h. Okay, so there's some black magic that I'm going to use right here. This limit is actually equal to 1. And that is because a man named Euler decided, he already did all the math and whatnot. He said that this is equal to 1. I'm not going to show that on here because that's a lot of work. So we are just going to take it for granted that that limit is equal to 1. And then with our other limit here on the right side, our h's cancel out, right? So I'm going to go ahead and simplify this out. Okay, so now I'm at the point where I can use direct substitution and I can plug this limit in. So we have the e to the x on the outside, x squared plus, and now I'm going to plug in h going to 0. So 2x e to the power of 0 plus 0 e to the power of 0. When I simplify this out, I get e to the x, and on the inside we get x squared plus 2x. The 0 times e to the 0 is just 0, and also e to the 0 is equal to 1. So now if I distribute this in, I get e to the x times x squared plus e to the x times 2x, which actually I'm going to go ahead and rewrite that as x squared e to the x plus 2x e to the x. No reason for that. That's just the order I like it to be in. So now we had our original function was x squared e to the x, and we have our derivative is x squared e to the x plus 2x e to the x. As we can see, it's not as straightforward as we might like it to be, but I do see some similarities. I have my x squared is in the derivative along with the derivative of x squared. So the derivative, now similarly for e to the x, the derivative of e to the x is just itself. So here it's hard to see where the derivative is because we have an e to the x in both of these quantities. But let's go ahead and use the product rule to see what's happening here. So when I have two quantities being multiplied by each other, I have f of x times g of x. I take my f of x and I have the derivative of f of x. But I multiply it first with the derivative of g of x and second with the normal g of x. And then I add those two terms together, so these get added. So that's super similar to what I had going on in this original problem. My f of x was my first term, which was x squared. And then f prime of x, its first derivative, was 2x. Now with e to the x, that was our second term, right? That was our g of x, and the derivative was just equal to itself. That's why this one was still g of x. And then we added those two together. So that is how we can skip that whole entire thing. I'm going to show it. We did all of this work, or we could just do product rule. So it is a bit of memorization. We do need to memorize the formula, but it is to save us a bit of time. So let's go ahead and apply the product rule. We have our first problem, f of x is equal to x minus 1 times 3x plus 4. So I like to separate these to see the two different functions. First, I have x minus 1, and I'm just going to label this f of x. So this is equal to x minus 1, and I also want to find the derivative. F prime of x is just equal to 1 in this case. Now I look at my second term, and this is going to be my g of x. And I also need to find its first derivative. So I have the first derivative of g of x is equal to 3. So this is why I write this out, is because all I do is I take the cross product and I add them together. So first I multiply f prime of x is equal to x minus 1 times 3. That's the first cross. And then I just add together the second cross. So 1 times 3x plus 4. If I multiply this out, I get 3x minus 3 plus 3x plus 4. Combining like terms, 3x plus 3x is 6x, and then minus 3 plus 4 is plus 1. And so that's how I can use the product rule to get the derivative instead of having to use the limit definition every time. If you agree, this way was way faster. Let's go ahead and see another problem. It's supposed to be plus right here, and I'm going to go ahead and label my functions. Alrighty, so now we need to find our derivative. So our first derivative of f is equal to 12y to the power of 3 plus 2y. Now for our g of y, g prime of y is equal to 2y minus 0, so I'm not going to write that out. And now we just take their cross products and we're going to add it together. So I get my actual derivative, this was g prime of y, is equal to the first product, so 3y to the power of 4 plus y squared times 2y. Now I'm going to add my second product, 12y to the power of 3 plus 2y times y squared minus 4. Looks like we got to do some math for this, so I'm going to distribute it out. So I'm going to go ahead and combine some like terms here. I'm going to look for my y to the power of 5s. Looks like that's all I got, so that is equal to 18y to the power of 5. Next, I'm going to look for my y's to the power of 3. So here I take negative 48 and I add 2, so I get minus 44y to the power of 3. And then I just got my tail end, so minus 8y. And that's our derivative. Let's see another example here. In this next one, we don't need to use product rule for the entire derivative because our only product rule is going to be right here. So I'm going to go ahead and label my parts. Our next step is to find the derivative. So f prime of x is equal to 2, and then g prime of x is just equal to e to the x. Let's go ahead and do our cross product, and that will give us g prime of x. So first we have 2x times e to the power of x, and then we add our second product, so 2 times e to the x. But remember, we weren't doing product rule for this whole thing. It's really easy to get lost in the process. We first need to take the derivative of our first term. So the derivative of 6x is just 6, right? And now we need to subtract this entire product rule because we're subtracting right here. So when I distribute that out, I get 6 minus 2x e to the power of x minus 2e to the power of x. We have one more example here, and before we get into the product rule, I'm actually going to rewrite it because I notice here I have fraction. So I'm going to rewrite this. H of x is equal to 1 plus x to the power of negative 2. So I brought that up and I made the exponent negative. And then that's being multiplied by x squared plus 2. I'm going to go ahead and label my parts now. Okay, let's find our derivatives. So for f of x, the derivative of 1 just goes to 0. So now I'm just going to use power rule on that x to the negative 2. So I get negative 2x to the negative 1 because I have to add 1 to the exponent. And then for g prime of x, I'm just going to get 2x plus 0. So now I'm just going to do my little crossies in order to get the first derivative. I want to simplify this a little bit, so I'm going to go ahead and multiply it out. So here I get 2x plus 2x to the negative 1. When I multiply these two products together, I add their exponents. This one has a secret exponent of 1, so 1 minus 2 is equal to negative 1. I'm going to do the same thing right here. So actually, I notice I have a positive 2x and a negative 2x, and I can actually combine these two together. So this is equal to negative 2x to the negative 1. If we wanted to rewrite that, we could rewrite it as negative 2 over x. And that is our derivative using product rule. So that's all I have for us today. If you enjoyed this video, please leave a thumbs up and leave comments of other problems, any confusions that you had, or other topics you'd like to see. Thanks for watching.